Hello future tech leaders, I am Sindhuja. Based on my own experience, I know that learning the right skills can shape our future. What if I say learning was as thrilled as the tech world itself? There we go. A cloud foundation, that's exactly what you will experience. From day one, you will be immersed in the interactive sessions and expert-led courses that covers most of the widely used technologies in the zone of data science to cloud computing, which brings more light to the life of a techie. I'm so excited to help you and unlock the true potential of a technology. Well, then why to wait? Let's see what it unfolds.
Today also we are going to talk about a very important concept called rule resolution. This is something that happens in the runtime. Far it was all about the design time aspects, but now it is going to be the execution. We will try to understand how Pega is going to execute the rules. Because when you take a huge enterprise application, a lot of rules could be there. A lot of versions could be there. And the interesting factor here is you can have the same rule name for different rule types. Correct. And it could be in different classes. Suppose there is a section called Get Personal Information. I can have it under the recruitment class, I can have it in the work class, or I can have it in the organization layer. I can have it in the framework layer. The same section is available in multiple layers of your application, and it could have its own specific version as well. How is the system identifying which one to pick under which context? It's not just randomly picking anything. No, there's an entire algorithm that runs in the backend. This algorithm of identifying the most appropriate rule for any given instance or for any given situation is called rule resolution. Rule resolution is like a search algorithm. I find the appropriate rule for the given context. This happens each time you execute your application and each time you run a business transaction. Each time you run a case type, this rule resolution algorithm tries to find out the most appropriate rule for the given context. Now when I say rule resolution going forward, I'll call this RR. This RR is for the rules, exclusively for the rules of your application. It applies for all the rule instance classes. Any class that it extended from rule will be part of this algorithm. Be it your properties, rule, object property, rule HTML sections, your activities, data transforms, decision rules, declarative rules, everything that's extended from rule will come under the process of rule resolution. What is not included is obviously your work classes, your data classes, something like data-admin-address or -admin-operator IDs. They will not be part of the rule resolution. Anything other than rule will not be included in the org code. My end result is going to be that for a given context, what is the best rule that has to be executed for this given scenario? That's what my RR is going to give. I understood the outcome, which is giving a good or a correct rule for the given context. But when I say it as a search algorithm, what are you searching for or what is the base for your search? Because when a person is missing, I need to give you some details about that person. You can find the person for me. I'll give you some photograph. I'll give you his details last seen. I'll give you his other physical appearance related details and all you can find them. Similarly here, also there need to be certain inputs for this RR. You give the inputs, RR will find the rule and it will give back to you. And what are those inputs? We have a lot of inputs that go into finding the rule here. What are those? The first one is going to be your unique identifier of the class. Sorry, unique identifier of the rule. Which obviously it's like the identifier or the unique identifier, the name of your rule. Then the rule type, the rule name, its version. And then in case if there's any circumstances relating to that particular rule. Then the availability of the rule, then user's privilege. Considering all these things, we will try to, find out. We, as in the system, is going to find out the most appropriate rule for your given context for which matches all of your inputs regarding the RR. Now let's go ahead. We will see what is this algorithm looks like. This is the process that goes into your RR. This is a standardized process. We might need to memorize it initially, but once you start working onto it, you will be able to, just get the logic out. The first thing that happens is finding the rules in the rules cache. Pega gives us different caches for different entities, one of which is your rules cache. This is going to store all the rules related to your application. First, the system goes and checks for the rule in the rules cache. Now, if it finds the rule, then it will check whether it is a best match or not. What is the best match here? I'll talk about it. It will first check whether it is a best match or not. After checking for a best match, it will check whether the rule is blocked. What is the availability of the rule? Is it available for execution or is it blocked? Let's take the positive scenario. It's not blocked. Then, finally, it checks whether the user has access to it or not, whether the user has any privilege to access that particular rule or not. If yes, then finally that one rule is picked. It starts with finding the rules in the rules cache. It's picked. But there are, alternate aspects here. What if the rule is not found at all? What if the rule is not available in the rules cache? Then what should we do? Then the system populates the rules cache. First, it will try to populate the cache. Then it will start checking again. This continues until the best match is formed. Now let's take an example here. Let us take some. I'm going to take a simple scenario here to understand this better. I think just before jumping onto it, let me know if you have observed this particular thing. Initially, when you have designed your case types or when you are running your application for the very first time, when you are running your case instance, for the very first time. It took a bit longer. Slowly you have, started creating more and more rules, more and more case instances. The system gained speed. Did you observe this? This is because of your rule resolution algorithm. Initially, your rules cache is going to be empty. The first time you are running the application, your rules cache is empty. The system should start populating the rules cache first. It has to identify the correct rule for every instance and it has to place it in the rules cache. And later on, when you start creating more and more rules, the cache is already generated. The system will just look after those rules that you have newly created. It doesn't need to go back for the entire new set of application. This population of rules cache, this is probably done for the first time and that's why it takes up a bit longer for you to execute the rules. Here, what we'll do is this population of rules cache is also a separate process in itself. It's not like whatever comes into picture, it'll just be populate in the cache. No, again, the system considers this as a separate process in order to populate the cache. Let's see that process as well. You can understand this as a sub-process within your R. What does it say? It has like 6 different steps involved here. The first one says choose rules with the correct purpose. We will be experimenting on each one of it today. But for now, just try to understand what they mean. Choose rules with the correct purpose. Correct purpose, it says. But what purpose? The purpose is going to be the name of your rule, the rule type, the class, the version. Considering all of this, you would like the system would choose the rules with the correct purpose. Then discarding rules that are not available. Once you get a list of rules here in the first step, now the system slowly starts eliminating the rest. This is going to be an elimination process. Suppose you start with 20 rules with the correct purpose. Finally, when you're setting the cache, you might end up with just 4 or 5. Now the second step is discarding rules that are not available. I'm going to check the availability of the rules. If they are not available, please discard them. Then next, filtering the rule sets and versions the user has access to. Again, I have to check whether the user has access to that particular rule set and version or not. Again, few of those would get eliminated here. Then discard rules that are not in the inheritance path. I should discard rules that are not part of my ancestor tree. Then finally, I would rank the rule sets. Sorry, I would rank the rules and then I would set the cache. This is how the process is going to be. But instead of looking at it like this, let's take a simple scenario. Let's take one of the rule and we'll see how the system is going to, find the best match for a particular given instance. I am going to consider a section this time. My section name is Create Request. The section called Create Request is available, this rule. Now I would like to understand how the system is going to give me the appropriate or the correct rule instance. we are going to consider a section rule called create request, and we will see how we would end up with a particular outcome for this algorithm. The first step is going to be initially considering. This is the very first time we are running this application. In that case, what happens is first your rules cache is going to be empty. Now the system will start the process of populating your rules cache. What's the first step in your population? Choose all instances with correct purpose. What comes with the purpose here is the name of your rule, the rule type, classes. You observe the rule name is create request and the rule type is section, but it is available in almost around 15 classes. It is available in TGB purchasing work that purchase request. It is available in TGB purchasing work dash purchase order. It's available in TGB purchasing work. It is available in TGB. My rule that we spoke about, which is create request, is available in all different classes. It could be of different versions, but the system first makes a list of all ones with the correct purpose. We have all of them as rule candidates. They are all candidates. Finally, one of which is to be executed. This happens for each and every rule in your application. Consider this example is just for one rule. Imagine how many number of rules you will have in your application. And for each of it, identifying the appropriate rule candidate is what is a lot of from the system's perspective. Suppose your create request one is already, part of your application, already used it multiple times, which means the rule candidate for it is already available. The rules cache is populated. The system will just pick it from them. But whereas for your create request, which you have newly created, the system will go with this cache population first. It will go with all the elimination process and all, then only it will be executed. Now you have already created a new version of the rule, which means the older one has to be extended in some or the other way. You don't want the older version, correct? Now the system considers the older one. There is no point of having a version. For each change that you make, it could be on the rule availability, it could be on the versioning side, it could be on the circumstances inside or whatever. The system always checks whether this rule is correct for the given context or not. If it's already available in the cache, then it doesn't need to. If you have created a new version or made some changes or not, then yes, it will go back. Populate the cache first, then it will check for the rest of the steps. My step 1 has now, I have around, around 10 to 15 rules with the correct instances. These are my rule candidates. Slowly, we will start the elimination process and we will see how many we would end up with. Now what is the second step is discard the rules with availability set as not available. Now for all the given rule candidates, I'm going to check the availability. If for any rule candidate the availability is not available, I will be discarding. Out of all of these, I see the highlighted ones are set to not available. directly. The system is going to discard these rules from the rule candidate. Like I said, as an elimination process, now we have a lesser number of rule candidates. Then the third step is discarding inapplicable rule sets and versions. What is this inapplicable rule set and version? How do I say whether that's inapplicable or not? This depends upon the operator's rule set list. Now each of your rule candidate is compared against the operator rule set list. If it falls within the operator list, yes, those would be available. If not, they would be discarded. Now there's a simple logic that goes behind. Look at this third bullet point here. I'm going to read this out. To be included in the results, each rule candidate must belong to a rule set listed on the operator list. First standard or the first thumb rule is, if it has to be included, it has to be part of the operator rule set list. Then each must have the same major version. We are considering the major version here and it has to be the same. Whereas minor version can be less than or equal to the one mentioned on the operator profile. What is happening? Two things. One is it has to be on the operator rule set list. The second one is major version is same, whereas minor can be less than or equal to. How do we deal with this? Let's look at an example. Operator rule set list here. Look at the bullet point 4 where we are considering operators rule set list has two rule sets, purchasing O2 and TGB O3. I will compare all the given rule candidates with these two rule sets. For purchasing, it has to be O1, O3, O4. I see different rule sets available here purchasing different versions. T, G, B versions are there, quoting and SCC are there. Even though the rule set is same, the major version is different. The major version we are going to consider is O2 because for purchasing I need to look after O2. Anything other than this major version will be discarded. All the ones with O1 are discarded. Then what else will be discarded? Major version is same, but minor version is not same. It's not even less also. Yes, this is also discarded. Perfect. Then what about these? Again, the highlighted one is T, G, B. It has to be O3, O1 discarded because the major version does not match. This T, G, B related ones are also discarded. And then finally, I have quoting and say E. I don't need to check the major minor versions and all directly. They are not available on the list to discard. Now, after this step, I will end up with probably 4, 5, 6, 7, 8, probably 9 rule candidates. I am left with, after discarding inapplicable rule sets and versions. Then what happens is, this time discard the candidates that are not part of the ancestor tree, which means if your rule candidate is not a part of the ancestral hierarchy, you can remove them from the rule candidates. Here comes your inheritance concept. The rules that are part of your pattern or direct inheritance will be allowed, whereas the rest of those will be discarded. How is that going to happen? We will look at the class structures here. Here, if you observe, TGB, purchasing work, purchase request is there. Whereas work dash purchase order is also available, but are these parent and child classes? Purchase request and purchase. They are sort of siblings, but they are not parent and child. There comes your TGB purchasing work, which is like a parent class, yes, and then TGB, which is organization layer. Again, it's a parent class. Here, we will try to check whichever is not part of the ancestor tree directly. Those would be discarded. We would just look at we, as in the system, is going to look at the inheritance pattern, and whichever is probably the odd one out or not, part of the ancestor tree will be discarded. The highlighted one, the purchase order rule candidate, is going to be discarded. This elimination process of like 2 or 3 steps involved, where we have eliminated some rule candidates and all is done. Now almost the last step is going to be ranking the remaining rule candidates. You would give them a particular order. You will sort those rules because this order is going to be. Now, this ranking involves 3 substeps. You have to sort it, then again check if any rules are set to withdraw. Remove them. Then identify the default rule candidate. 3 substeps are involved. What happens in the sorting or what is considered in the sorting is the sorting criteria is dependent upon this. First your class is checked, then the rule set, if at all any circumstances variables are available. If yes, is it going to be a template based or is it going to be, date based, or those things are checked and then your version is checked. Let's see how the sorting works. With all those that I'm left with, it is now being sorted. You see first the current class that you're handling, which is work-purchase request. All the instances are listed out and you can see the version as well. They're sorted in the descending order of your version. O2 10 is on the highest priority. Then comes your on 5, then O2 on 1. And then next it checks in the parent class. And then for each of the class, according to the version and according to any circumstances qualifiers that we have, those will be listed out like this. But the top priority is always given to your current classes and the topmost questions. Once it is sorted, what next? The next criteria is going to be removing the rules that are set to withdraw. There's one more rule, availability other than available blocked, not available. It is going to be withdrawn. Now, once it is sorted, we are going to check if any rules are set to withdraw. If yes, then they will be discarded. But here there is a trick here. Withdrawn rules are anyways discarded. As per the algorithm, they're anyways discarded. The additional factor here is any other rule candidates having the exact same properties like that withdrawn rule, they will also be discarded. What comes here is an interesting aspect. Withdrawn rules are anyways discarded. Now the system is going to check if there are any other rule candidates with the same properties as the withdrawn rule, and if it finds some, then those will also be discarded. That's why you see here 3 rule candidates are highlighted. The first one is withdrawn anyways. It is out of the question. But the system checks, are there any other rules with the same kind of properties? I mean, be it your classes, the rules set. It will check the version and version as in. It is going to check the major version first. It finds that there are 2 other rule candidates with the same kind of properties. All 3 are discarded. One advantage with this kind of withdrawn rules, we'll be talking about that. Rest all far is if they satisfy the criteria, they're discarded. But here with the withdrawn, it has got some added capability, not withdrawn rule. It will also take away any other rules that match with the withdrawn rule. The step before, this is going to be your sorting. The top one is going to be your O2. O1, O11 would be available. That will still be there, whereas the rest of these 3 will still be discarded. The top one is available. That will still be there, but the rest of these withdrawn ones will be discarded. That's why this sorting is also an important aspect here. One step is entirely for the sorting process. If you don't have a withdrawn rule, suppose now in the stack or in the rule candidates you don't have any withdrawn rule, then the system is not just, it's not going to discard anything. Earlier, your withdrawn rule, whatever you have changed, that will be available along with the other rules with the same properties that you have. They will also be involved in the algorithm. You will have that called O2, O110, which is now available. Along with that, the O215 and O211 will also be available. See, one more thing here is when probably when you're moving the versions, which means it might be through your skimming or lock and roll, whatever it is that time. Also, this rule availability counts. It's not like whatever you move, it is not moved. A few things will be left behind. All your withdrawn rules, when you change, the major version will be discarded. When you're changing the version, they will definitely be impacted. If you decide that the rule is not probably you no longer want to use the rule, and that's the purpose you have withdrawn. The system will discard those rules when you're dealing with this process of skimming and all. Here, if you observe, let me just do this. See, now look at this part where, depending upon the rule availability, it is decided whether the rule is carry forwarded or not. If you observe, it's with respect to the major version. The withdrawn rules are not moved forward, they are discarded at that point itself. And the major concern is going to be my major version only, that's what I would be checking with respect to the other rule candidates. All coming back again. Yes, my withdrawn rules give me, an extra privilege that the remaining ones with the same properties will also be discarded. Fine. Then comes the last step is determining the default rule candidate. What is default rule candidate? Is in the given sorted order system checks. Is there any rule candidate without any qualifier, no circumstances, nothing? If it doesn't have any qualifier, the first one that the system finds out is going to be your default rule candidate. Here, of which I found that the third 1/3 rule candidate is the first candidate without any qualifiers. This grayed out one is going to be my default rule candidate. Good, I found it. Then what next? All the rules below the default rule candidate will be discarded. All the rules below the rule candidate will be discarded. Finally, I am now left with the 3 rule candidates, out of which one is the default. One and other 2 have circumstances. I am left with the 3 rule candidates like this, with which the cache is popped. Now I started up with around 20 rule candidates. Now I ended up with 3 rules to set the rules cache. You have just completed this part of the process, which is for populating your rules cache. Let's continue the next. What should happen is this part is completed. My population of rules cache is done. Then what happens is I have 3 steps involved: finding the best match, check rule blocked, and then check user access. 3 things, let's see. The first one is finding the best instance. What is the best instance here? Of the 3 candidates, I see 2 of them are related to circumstances and one is the base rule. For example, the first one is based out of a qualifier called sum. Supplier is equal to restricted. If on the given context of the case execution, if some supplier property is set to restricted, then this highlighted rule is going to be picked. This is completely a context-based thing that the system checks. A property called supplier is there, and if that is set to restricted, this highlighted rule is. If not now, if supplier is not restricted, then what happens? Then it is discarded and the system checks for the next available option. Here there is one more qualifier, which is date less than 1st June. If that is the case, highlighted one is picked. If not, that is also discarded. And then finally, one rule can be made. One of the others match to my criteria. The system is going to consider the base rule. This is going to be my best instance now. The next step is checking if it is blocked. Is this rule available or is it blocked? Will be checked. No, this rule is available only fine. Probably your last step is going to be check if there are any privileges for the user. We know privileges are for each specific rule for an operator to access it. Check if this called operator who is working on, does he have access to run that or execute that particular rule. There is no privilege defined here. The user does not need any special privileges or special access required. Yes, he can execute this rule. Finally, towards the end, the user is able to run this transaction and yes, the correct outcome for this called search algorithm for create request is going to end up with this rule candidate being executed from TGB purchasing work and then of the version 02, 01 and 05. Request. This happens for each and every rule that you work with. Imagine how this process works when you're dealing with an enterprise application. For each rule, the system checks the rule candidates. It goes through the entire process whenever you make some changes on the availabilities, whenever you make some changes on the versions or the classes. Each of these inputs, whenever your inputs would change accordingly, your algorithm has to act. My inputs, your qualifiers, and if at all there's any circumstances, the names, the rule types, and the versions, the rule availabilities. Any change to one of these entities and the rules cache is populated accordingly. New default rule candidates find out and accordingly the system takes it forward. All this is how the entire process is going to work. This is like a standard process. I mean, you can just memorize it on your fingertips once you start debugging things, and all this is the process that we check. In runtime, in the real time, why a particular rule is picked, why not the other? Why not? A new version is not picking up, why? Then we have to, come back and check these steps. Is it being correctly pointed out on the class, or does the user have access or not? We need to, check all of these things. I think that's all about rule resolution. An important one. Once we, go through the steps and all, it is quite easy. Sure then. Thank you. Have a good day. And finally, do not forget to like, share and subscribe to our channel.